So yeah, let me here, I'll put this thing back on speaker mode, and it is Option Y on Mac or Alt Y on Windows to raise your hand. Oh, Harold, would you like to go first, sir?
Yes, I do. Ross, why don't you, did it occur to you to try a small working model first? Because that one is so big. I mean, there's so much expenditure of cash, and any mistake is expensive, or if you have to make any correction, it is expensive, any adjustment. I mean, did you try working a small model that is safer and you can make a lot of variation as you learn about it? I mean, did you try that first?
Actually, well, I do have a smaller one back in my bedroom that's not as big as this, and I did what Mike Gamble does, and he it's called Swiss cheesing it, where he cuts drills a lot of holes in it to make it lighter weight. And I actually used to do that. I used to drag race. I used to do stuff like that with cars, drill out the metal bodies of cars and make them lighter. So I did that with the machine way back in my bedroom, which is a lot lighter than this frame. But it was getting to the point of being dangerous. But yeah, I mean, optimally, most of my, like Cleveland Savage has been telling me, you know, I should make one like this small, like, you know what I mean, 10 inches, 12,
Yes,
like
yes.
small, like a 3D, like just a 3D printed one. And I mean, that's a good idea. I mean, I'm actually a 3D printer. I could actually do that. I don't have the software right now, but I don't have a 3D printer at home. Cleveland Savage has a 3D printer. I might see if he wants to, because he's really good at 3D printing as well and making things and that. But yeah, that would probably have been better. But I got lucky because I actually worked in junk removal for years in the weekends, so I've got all this pretty much for free. I mean, this has got to be like $10,000 worth of aluminum and steel and wood and motors and chain. It's got to be at least $10,000-$20,000 worth of stuff, and I got it pretty much almost all for free.
Oh, boy, you should make the same thing on the size that would fit on a shoebox. And when you do something like that, not only can you go high RPM, but you'll be able to measure the forces with a small scale. And then you have a better idea how good it works and how to make it better. And you can accelerate your progress a lot faster, because something like that, number one, it is kind of look like unsafe, you know, because the way it's shaking, I mean, if that thing moves too much, if you put too much thrust and it shake too much, you know, it can go through one of the walls. So I think you should try the small shoebox, because, I mean, you find out, you know, you can make a lot of fast progress that way.
Yeah, this thing could definitely kill you. Back when I was back when I was first working on it, one of these gyroscopes just went out. It blew up and it just shot shrapnel. Like it almost cut my head off. You know, it went into everything. So I would have had my head cut off if I got hit by one of them pieces. And then these wires, like if that wire were to break at the bottom, it'd be like a weed whacker, like a big weed whacker swinging a wire around and around. It would just chop my arm off or chop my head off. So yeah, this thing is extremely dangerous. I mean, I almost broke my thumb the other day. Just got crushed into one of those like little things. It just got crushed my thumb.
Look, go with a small machine. You know, from experience, I'm telling you, I had it. One time, one small machine, one of my propulsion devices that I built, one of the magnets flew off and it went like a bullet. Fortunately, I was not on the way. Recently, you know, I'm talking about in the last 10 days, I was making a demonstration to some friend of one, my machine working, and again, one of the magnets flew up, it went like a bullet. Fortunately, nobody got hurt. So that's what I'm saying. Try the smaller version. It will be safer for you, and you will learn a lot faster. You know, whatever it takes. So go with the small.
I want to say you're actually kind of like doing the same kind of thing that we're doing here, because with your machines, I saw you on YouTube.
Yes.
you've got the magnets all the way around on the ends.
Yeah, exactly. One of them, you know, the one in the pendulum rotating, one of that one, the magnet actually flew off. You know, and I've been able to produce as many as 14 pounds of force measuring. And the danger is, you know, that it can fly off one of those magnets because I'm using the Ampere orthogonal magnetic field that produces a reactionary force, which my patent is about to issue very soon. And yes, you know, that's basically what I'm talking about. So if you make it a small one, you should be able to make progress a lot faster, and you can see, because something that big is going to slow you down a lot. I think, you know, you can use your ingenuity, your intuition, you know, and you make a small machine, you see it working. And not only that, you can make a lot more changes. You can make a lot more invention, make a faster progress. But yes, you know, one of those machines, that's what I'm talking about, was demonstrated recently. Unfortunately, thank God, nobody got hurt. All right, hey, good. You're doing a good job. Keep making progress, okay?
Yeah, but I want to mention, like, when I was saying, like, you're like, you have the right idea, because you're messing with the weight all the way out at the periphery, instead of guys who are worried about tweaking the motor at the center and changing the speed there. You're actually like focusing with the magnets way out on the periphery.
Well,
That's
it's producing propulsion force, and that's what is making the arm turn all the way around.
Yeah.
And I thought, you know, so I'm still working with that because there's many variations to the same thing. I have built many of them. I have 4 patents pending right now. One is about to issue. And so, and that's what I said, build the small machine. You will make a lot of progress faster. You will learn a lot more, and it will cost you a lot less. And that's what's important. Keep on working. I mean, you're doing something good, you know? That's exciting to see people like you doing. Sooner will be my turn to be there and show my machine, you know, even though I have it in YouTube, but I will be presenting the theories and everything, you know, with the equation, you know, and but that's good. Hey, thank you. Good luck. Keep on working.
Yeah, good luck to you, man. Thank you.
Thank you.
Awesome. Okay, well, so let me go to Riccardo Storti next. Mr. Storti?
Yeah, g'day. Thanks for that, Tim. G'day, Ross. Look, really well done on what you put together there. It's certainly visually impressive. I'll give you that. And I was a bit fearful for your safety, to be honest, before you turned it on.
Yeah, me too.
And I'm wondering how you can manage to still have a polished floor after having that on it. But just seeing you turn it around, I would have thought it would have scratched your polished floorboards there. But look, my question is, now, as an engineer, and I'm a mechanical engineer, right? So that's of particular interest to me. Now, looking at it, the very first thing that I'm going to think as an engineer looking at that is that if you get any propulsion out of it, the very first thing I'm going to think is, well, it's just mechanical friction, you know, little bits of unbalancing here and there, and that's what makes it look like propulsion. What's your answer to that?
Yeah, because I mean, like I said in the last, I don't think you were here in the last one, but I actually do not agree that like the Cook propulsion device, the Dean and the Thornton and the gyroscopic inertial thruster, I actually do not think they work. I think they don't work. I think that they can move across the ground like a washing machine, an unbalanced washing machine, and I think that that's not actually going to work in space. So I agree with you. You know, so most machines, I believe, you know, up until hopefully, I think, you know, I think this works, but I mean, I'm not 100% positive. But yeah, I believe that just because something moves across the ground doesn't prove that it could work in space. Because I mean, I could stand on a skateboard and jiggle my hips to the side, and I could make myself move. You know what I mean? but that doesn't prove anything. That doesn't mean I can move in space. The same thing with a washing machine. I can have a washing machine and throw a blanket on one side and it's unbalanced and it could jiggle across the ground. That's not proof that there's anything going on here. So ultimately, yeah, I would have to do something other than putting it on wheels. Like Brian St. Clair was saying, put it on a seesaw where it's off balance like this. You know, the machine would be like over on this side down, and then when you turn it on, it would have to lift itself off the ground completely, so that there's no way it could be anything else that's doing it. I don't see how any other force could create a seesaw to move like that. Like when you turn it on, it would go like this. And then you turn it off, it would go like this. And then you turn it on, it would go like this. And then you turn it off, it would go back.
So the answer really is that you'd be looking at designing an experimental environment that proves the point, rather than trying to eliminate any frictional contributions like the unbalanced washing machine you're talking about. So you're saying that by choosing the right environment, like a seesaw or something similar to that, proves the point, and overcomes people's doubt regarding friction of components and causing imbalance and stuff like that.
Yeah, and ultimately the best would be to take this out into like a warehouse, one of my friend's warehouses, and dangle it down from like a bunch of braided stainless steel wires with like a 500-foot tall ceiling, and then turn it on. It's sitting there just dangling, and then when it turns on, it moves like 20 feet out and stays at like a 45-degree angle, way out on a 45-degree angle, and it just sits there. And then you turn it off, and then it comes back. It comes back to normal. And then you turn it back on, and then it goes. It floats. It floats out at a 45-degree angle, 20 feet out on a wire, and it sits out there while it's on. And then you turn it off, and then it comes back. So that would be the ultimate way to prove that it's really working.
All right, good. Thanks for that.
Awesome. Riccardo, thank you, sir. Let me see who was next. Somebody else had their hand up too. Oh, John did. John, do you still have a question, or? Let me see here. John Brandenburg had his hand up a moment ago. Okay, well, does anyone else have questions for Ross? We got about 10 minutes left before we go to Mark.
Jonathan said, permanent magnets, mega ultra super strong neodymium. Actually, I agree with him. Like last time I mentioned, I'm actually going to eventually, obviously this whole machine is kind of crazy. I mean, I don't want to even patent this thing. It's so crazy. But in my mind, I don't want to show you all, but I have something cooked up where instead of having 2 gyroscopes, it would be 1 gyroscope, and I would figure out a way like Harold Tavares is doing with the magnets. Not exactly like he's doing. He's really close to what I'm doing, but not quite. But they'd be, he has them in a circle around. But I think you have to have them linearly in a certain pointed in a straight direction around one side. And once I get that machine, and that I would do, like he said, build it like as big as a shoebox, not even, or maybe 12 inches or something. But that, what I got cooked up on my mind, would do the same thing as this, but be about the size of a shoebox. And it would have no springs, because these are actual physical real springs. What Jonathan's saying here is you can also use magnets, and I agree. I would like to get rid of the springs completely and go with just magnets alone. where there's no physical wear, because magnets act like springs. You know what I mean? So you could either have it where, you know, where they come together and they repel, or you can have it where they're separating apart and they're trying to come together. So either way, they have a spring-like, you know, they work kind of like springs, but there's no physical wear. Like in these springs are actual metal springs that are really getting worn over time.
Yeah.
And, you know.
Well, Ross, let me go to, actually, if it's okay, I know Robert had his hand up first, but let me go to Anthony Williams. I don't think Anthony has ever asked a question at APEC before. So Anthony, go for it, sir. And here, let me find my mouse. Yeah.
Do you have a mic? You don't have a microphone, Anthony.
Okay. No, Anthony, you have a mic, but it looks like your mic volume is bottomed out. We can't hear you talking. Sorry. And I started sneezing when I was going to mention that.
He might have to shut down his Zoom and come back.
Did that fix it?
That fixed it. That fixed it.
Yeah, this completely selected different microphones for some reason. Okay, two things. I was wondering, have you heard of the Robert Cook propulsion patents?
Yes.
His ideas?
Yes.
I was thinking between that and then there's another video that says, I don't know if this is a legitimate video, but it says ISA inertial space propulsion.
I've seen. I know
that
guy too. I know him too. I know Robert Cook's son, Robert Leighton Cook.
Oh, okay.
Yeah, he died. He lived in North Carolina, one state away from me. And you know, I don't know. Did you know he died a little while ago? His son died, so they're both dead now. The both Cooks are both dead. Yeah, both Cooks are dead now.
I was thinking maybe having the one. I think it was part of the ISA that had like one wheel inside of the other.
Yeah, I've talked to that guy. He made it in 3D. It's on YouTube.
Right.
Yeah.
Yeah.
It's like a drum. It's like a drum.
Yeah.
It looks almost like a bell housing. Yeah.
I was thinking, definitely, man, dude, make that smaller. I'm really afraid that you're gonna get hurt with that thing. It's so big. It works. It comes apart on you. But
I do not agree that the International Space Agency, I don't think that theirs works. I don't think that it could work. That their theory is like they're trying to what I call it hula hooping themselves into space. They're trying to create an asymmetrical, like faster here and then slower, faster, slower, faster, slower, faster, slower, faster, slower, faster, slower, and they think that'll get you to lift up and float up, and I don't agree with that.
Yeah, I was thinking that the Cook thing might be more legit, but
it's the same thing.
Yeah.
The Cook machine is like he tries to fling these weights around and then slow it, and then fling the weights around and then slow, and then fling the weights around, slow, and then fling. I don't agree with that. I don't think that's right. I think they're focusing on the outward centripetal force, or the centrifugal force, and they think that that's like when you swing a baseball bat and you kind of feel it pull you. They think, oh, that's a pulling force. It's not.
Right.
Because you think it's pulling you, but you're pulling it too. So you're both pulling each other. It's not pulling you. It's not, if you swing a baseball bat in front of you, it's not going to like pull you forward. You could say the same thing. I'm pulling it backward. You know what I mean? It's the same thing. You're just in balance.
Right.
You're both just in balance. So you can't focus on that whole outward centrifugal force stuff that the Cook does, the Dean, the Thornton. You can't, that's wrong. That's the wrong way of thinking about it. You have to do some crazy idea where you reach out and you actually touch the periphery of the gyroscope itself. And then you do it with this straight braided stainless steel wire that's always straight, that's grabbing it and slowing it down, speeding up, slowing it down, but at 90-degree angles.
Have you tried putting it on something with wheels? Like
Yeah.
whatever they call the mechanics thing that they lay on?
Yeah, I want to like lay the whole thing on
Yeah.
its side. And then, you know, I'm gonna get a platform of wheels here, like
Yeah, that would be nice to see.
like a long wooden beam here with, and then a big wheel out here, and then like 2 wheels down here. So it'd be like a big, huge tricycle, and then have this whole thing laying on its side and take it out into a parking lot. But like
Maybe
I
a
was
little
saying,
smaller.
yeah, but like I was saying, that still doesn't, a lot of people are going to be skeptical of that because
Right.
Even if something moves across the ground, it's not 100% proof. You know what I mean?
Have you
So
built it so big because smaller didn't work, or you just started out big?
I just started out big. I just go big. I used to work on drag racers and stuff, so I like
Oh,
power
cool.
stuff. So I used to drive 11-second 1967 Mercury Cougar, and
Oh, okay.
and I had access to all this stuff too. So I figured,
Yeah.
why not just go ahead and just go crazy with it, you know? Just
Do machining stuff?
I just have like hand tools and stuff. I don't even
Oh,
have
okay.
I don't even have a CNC or a lathe or any of that. I mean, I just got a welder recently, and I haven't even started welding really. I mean, but I do know, like Harold Tavares saying, like I should go and just get back into 3D printing and do it, like make something a smaller scale, because I could do, you know, but then I got to sit on the computer for hours and hours because I'm really good at it. But it takes so long making things in 3D. You have to sit at a computer, and a lot of times I like to just be out with the angle grinder or my hand drill, or just cutting wood, just actually sitting there physically doing stuff. So yeah, I probably should get back into 3D printing again.
Well, at least you're really testing the stuff instead of just on paper. Most people don't get that far.
And a lot of people just are a lot of talk, and I'm like, just build something. Like you got to do it. I mean, you can't just sit around and talk about stuff forever. You gotta, if you have something in your mind, just do it. You got to get out there and make it happen. Just put it together and just try, you know?
Yeah. Well, guys, if it's okay, because we're pushing pretty close. Anthony, if you're all set, let me go to Robert next. Then.
Yep, go for it.
Oh, okay, thank you, sir.
Thanks, Tim. Hi, Anthony. By the way, you make a great instructor. I mean, Ross.
Thank you.
Get your camera.
How is your system different from the systems? I thought they were already established, the inertial propulsion on satellites and the space station, but apparently not.
Yeah, there's right now, NASA, JPL, all of them, they think stuff like this is impossible. They have gyroscopes that stabilize the thing so it doesn't like turn out of sync. But I'm telling you, if you talk to a regular NASA person and you say, oh, you can propel something with gyroscopes, they're going to be like, cuckoo, you're crazy. That is supposed to be against Einstein, against the whole theory of relativity, the whole theory of you need you can't have an action without a equal and opposite reaction. It goes against Newton. It goes against, well, I don't think it does. I think they're wrong in their assumptions. I think they think it goes against Newton and Einstein. I just think that Einstein didn't think of someone creating such a crazy machine like this to get around his theory and be like, oh my God, like how the hell did you do that? You know, like I said last time, like Einstein said E equals mc squared. So energy is mass. And so I was mentioning that like when you fly a rocket and you shoot thrust out of the rocket, it's basically you're interacting with mass, with propellant, actual physical propellant that you have on the craft with you, and you're accelerating out one end linearly, and the rocket goes in the opposite direction linearly. So in this machine, it's a gyroscope, which is also a big physical massive thing that's like a propellant that's spinning around in a circle, around and around. But somewhere, I believe that there's a conversion going on. The guy who thought of this theory, he calls this the conversion of angular acceleration and angular deceleration into linear deceleration. So he's saying that as the gyroscope is being angularly decelerated and angularly accelerated at 90-degree angles, by having that stainless steel wire, the braided stainless steel wire we call the constant linear component, you always have that constant conversion happening. I call it an angular deflector. So you're reaching out and you're constant, like I showed on my stop motion video, you're reaching out, like, because he plays pool a lot and he likes to hit balls at like other balls that are going different angles, and he'll change their trajectory while he's hitting with a cue ball. So it's sort of like you're reaching out with like a cue stick and you're constantly hitting this one point. You're constantly deflecting.
Okay, yeah.
At all times, you're always kind of hitting it. So it's like this conversion process. You're converting the energy that's already going around in a circle into this kind of like always this one straight line hit. So it's always kind of getting tap, 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 tap down here at the springs. But my theory is that it's the 2 points are changing. They're changing their arcs. So they're trading off different arcs. And
as long as the forces don't equal and cancel each other out, there's a possibility to work then.
Yeah. Well, Robert, if it's okay, I'd like to go to John before we go to Mark Sokol. John, do you want to go now, sir?
Yes. I want to compliment you, Ross, on your mechanical ingenuity. Put some safety goggles on, please.
I need a helmet next.
You need a helmet. Yeah, and I recognize you're using scavenged stuff. And but anyway, I just want to compliment you on your ingenuity. But please be careful. If you could make something the size of a shoebox, you could put it on a roller skate or put it on in your bathtub and watch it motor around. If it's really creating a force, that would be a step forward. Of course, ultimately you'd want to go up on the Vomit Comet with a 0G and watch it float in space, float in the cabin. Anyway, remember the Wright brothers were a pair of bicycle repairmen. They were not physicists. They were not even engineers. So anyway, thank you. Thank you, though.
Yeah, the guy, Mike Marsden, who actually came up with the whole theory, where I tried to break his machine. I don't want to show you all his machine, because I think he might be trying to patent it, or maybe because I think he's worried the government's going to secretize it. Like he's been given a secrecy order in the past. He worked on the Apollo moon stuff, the engine, way back in the 60s, and at some point he worked for Sperry Rand Corporation, made a gyroscope that can measure speed, not velocity, and he says it's still under a secrecy order from the US DoD. So anyway, he's had that
The
happen.
government has an interest in these matters.
Yeah, so he's thinking that like if he were to patent it, at that point you've put yourself out there. I've actually read the law. Once you try to patent it, you've now opened yourself up to that potential, because the law specifically states that if the DoD feels this is a potential threat to national security, they'll just give you a letter that says this is secret. Sorry. This is way too dangerous to be out there in the public, and you get. I've read it says 2 years in prison with federal felony each time you ever mention that thing ever again, and it's not a joke. They'll give.
I'm glad you understand that, and be prepared for a tap on the shoulder if you get some success. I will, yes, point out that. We were funded by DARPA, and one of the DARPA people I dealt with said, I'm expecting people to come through the door any day. and tell me I can't work on this anymore. Now, that did not happen, but it has happened on other projects. And if you look at the DARPA policy on this, and which is general in the government reserves the right to take any idea it likes and classify it and use it without attribution. So that's because that's their job, is to defend the country. So anyway, carry on your good work, but please be careful.
Yeah. Well, on that note, we're just about out of time. So what I want to do next, I know Riccardo has his hand up. Riccardo, let me put your hand down for now. I want to go to gallery view and have everyone, again, big applause for Ross Small for building a remarkable machine. Ross, I hope to see demo footage from you, but as many people have said, please be super careful.
Safety goggles.
Safety goggles, stay away from
Helmet.
them. Yeah.
Loot some plexiglass from the local dump and put a plexiglass shield around so everybody can see what the thing is doing. But if
exactly.
chunks start flying,
safe,
at least slow them down.
as safe as you can possibly be. And Ross, thank you again for demoing. I'd love to have you back. And I know you're working with Brian St. Clair, and he's got stuff he's probably going to share with us as well. So, okay. So what I want to do now is